I'm setting up my 831C to make sound recordings, but I'll also set up the meter to collect some data at the same time. First, I'll name the data file loon. Then I'll move on to the SLM page where I'll choose to look at A weighting, which is the weighting that best takes into account how a human perceives sound. I'll look at this for both frequency and peak weighting. Here I change my detection rate to fast. This is about 8 times quicker than slow, so the reading on the meter will react faster to changes in the sound pressure level. Next, we'll look at octave bands and record both full and 1/3 octave bands. And also we want to be looking at A weighting here. Now let's take a look at LNs. LN is a way to define ambient noise or background noise. It is the decibel level that is exceeded for n% of a stated time period. I'm going to set the meter up to record L5, L10, L50, L90, L95, and L99. Oftentimes, when we talk about ambient noise, we're talking about the noise level that is exceeded 90% of the time, or L90. We'll talk more about this idea later. Moving on to the Control tab, set the meter to continuous run mode and enable measurement history with a measurement history time of 10 minutes. And enable interval time sync. We'll set the measurement to auto store once per day. The selections on this page will allow our measurement to auto save a new file each day, but to store chunks of data every 10 minutes. Now on to the time history tab. Let's enable time history and set our period to 5 seconds. I'll choose to store several parameters here. Next, we'll look at exceedance triggers. These are a set of defined sound pressure levels that will trigger an exceedance. Just to note that these utilize the current weighting, which is A in this case, and detector fast. We'll call the level at which we want an alert SPL1, and here we'll define it as 60 decibels. We'll come back and talk about this parameter more later. SPL2 would be a higher sound pressure level, and if we were monitoring for noise exceedance, for example at a construction site, it's a level at which we would want to raise an alarm that our sound level is too high. We'd want to do something immediately to reduce the noise if we reached SPL2. Peak 1, 2, and 3 can identify impulsive noise such as gunshots, so we're not really concerned about those levels for this application. Now on to event history. This is where we'll set up most of the parameters that govern when the meter will make sound recordings. We are only interested in events that last at least 1 second. So we'll make that the minimum duration. And we'll now set continuous duration to 3 seconds. This means that if our sound level drops below the triggering level for more than 3 seconds, the event, and thus the sound recording, will end. Here we will switch from triggering the event at a level number of decibels to dynamic triggering. And now we must define an offset. I'll choose 10 decibels. This means that when the A-weighted noise level is 10 decibels above ambient noise, an event is triggered and the sound recording will begin. Here's where it gets a little tricky. We can define ambient noise to be our L95, L90, or L80. Remember that L90 indicates the noise level that has exceeded 90% of the overall measurement time. The second number in the dynamic response, 1/3 or 1/2 or 1 decibel per minute, is the rate at which background noise can change. 1/3 is considered slow, 1/2 is normal, and 1 is fast. For our purposes and for most measurements, we'll stick with looking at the L90 with a normal rise rate of 1/2 decibel per minute. At the beginning of our measurement, LN doesn't really mean much. We don't have enough data to have an LN that is useful. So just to note that the starting background level is the SPL1, defined as 60 decibels a few pages back, minus the dynamic offset, defined here as 10 decibels. So in this case, our initial background level would be 50 decibels. I don't need to get an alert of any kind if there is an event, so I'll leave those unchecked. Now I'll enable event time history. Here we're defining the data that will be stored during our event. This section does not apply to sound recordings. We will include 10 1-second samples of data prior to the event and 10 1-second samples after the event. And our maximum number of samples, no matter how long the event actually lasts, will be 99. The next screen, Event Triggers, is grayed out because it only applies when we are using level triggering or static levels to trigger events. Markers are useful for attended measurements. I don't need to worry about those. And because sound can cause different levels of annoyance at different times of day, especially in residential areas, the meter lets us define what hours are considered day, evening, and night, and associate a penalty to the different time periods. I'll be leaving that as is. We don't need extremely high quality recordings for this exercise, and I want to make sure we have plenty of room to get recordings all night long. So I'll set my sample rate at 16 kilosamples per second, and we'll leave the range at normal and enable saving event sound. Our sound recording will go on until the event has completed, up to a maximum of the snapshot time. We'll set it to 20 seconds. Pre-trigger time is the number of seconds before the event is triggered that will be included in your recording. Here, I'll just set that to 1 second. You may be confused to see a Save Measurement Sound option here. This option works in conjunction with measurement history. We previously enabled measurement history and set our time to 10 minutes. If we turned Save Measurement Sound on, we would get a recording at the start of each measurement period, or every 10 minutes, in addition to the sound recordings of each event. I don't need that, so I'll leave it off. And to limit the amount of storage we'll need, we'll turn compression on. Sound files will be saved as compressed OGG files. We don't need to do anything with the Weather tab, and when I advance to the next screen, I'm asked if I want to save the settings. I'll save them in a setup file called Dynamic Trigger, and now I can transfer this setup to one or more meters so that I can begin sound recording.